Hey everyone, this is Tudor from Salt&Pepper. Welcome you to our workshop. Please, if there are any technical issues like the video or audio breaking, if I'm talking too fast or too slow, too loud or too quiet, even if you see a spider on my shoulder or anything, I hate spiders, jump on the chat and ping us. Also, please leave your comments and questions for anything that you'll find interesting this hour, as we're going to have a Q&A session. We're going to have a link for a Q&A on the slides. I'm going to also include it in the chat for easy access. First of all, I just want to say I'm happy to be here, and of course it's a real shame that we can't all be together, but we have to make the most of the times as they are right now. It's my first time around, so hope you enjoy it and find useful this workshop for a serverless application that generates, stores, and delivers invoices. Everything today is recorded, and the video will be available at the URL from the end of the presentation, together with the source code that we're going to play around with here today. All right, now back to me. My name is Tudor Gheorghiu. I'm a solutions architect and senior software developer for Salt&Pepper. I've been in the field for around a decade. Try to do as many things as possible along the way, from front-end to back-end systems, even design from time to time. But behind the scenes, there were a few things that just stuck with me more. My main weapon today is JavaScript, and I use it to abuse whatever serverless has to offer, and I use it as much as possible. I also consult on various projects. Most of them are in the fintech business, as that is my main color. My day-to-day item consists of being a senior developer for Jasper Card, which is a US-based startup in the fintech domain that offers credit cards to qualified expats and young professionals. The project is very dear and close to my heart, as I've written the very first lines of code there. I've written tons of bugs, of course, and basically it's the biggest project that I had at that time, with a huge responsibility that came with lots of rewards. All right, the agenda. In today's agenda, we're going to include a brief overview of what challenges we are trying to overcome and how we might do that. We're going to briefly talk about our chosen solution, meaning serverless computing. The method is getting more and more attention from the community every day, it seems, and I thought it's appropriate for this workshop. After this, in the second section, in the main section of the workshop, we'll just jump straight into it, and we're going to build a mock invoicing app. We will collect data from a database. We'll wrap it nicely in a PDF. We're going to back it up in our system, store it for our accounting team to have it later on, and of course, we're going to deliver it to the end customer. At the end, if time allows, we're going to talk about a sensitive subject, meaning limits, if they actually represent a threat, and in the cases we have to go beyond those limits, how can we do that? What are the challenges? So what are we trying to overcome with the exercise? What are we trying to accomplish? Of course, we're going to address some of the most common pitfalls in NodeJS, like unknowingly blocking the event loop. This is one of the biggest hidden enemies of a NodeJS developer. Or hitting storage limits. Storage nowadays is cheap, and it shouldn't be a concern at all at this time and age. Another thing that shouldn't be a blip on our radar are server hardware and performance parameters like CPU, RAM, I/O limits. These shouldn't be a problem, especially when we are talking about working with large execution volumes. One of the things that we're trying to accomplish is having a reduced cost of operation. Let's face it, nobody wants to pay more for a system that is used a few times a month, maybe even one time a month. Bonus, we're going to also, by using serverless, we're going to be avoiding creating a monolithic app. Nobody likes a big app with difficult to maintain code, spaghetti code. So why serverless computing? I realized brief moments before the workshop that I didn't include the slide about what is serverless, but I'm going to give a watered-down description about what it is. Serverless computing is an execution model where the cloud provider is responsible for executing pieces of code by dynamically allocating resources. The code is sent to the cloud provider. You configure the events that will trigger it, the security settings, like access to different resources, databases, and so on, and basically you are done. There is more to it, but as I told you, I'm going to water it down a bit. Serverless, what is introduced for the first time as a concept, it exists for a longer period, but it was introduced in 2014. And at the beginning, the workloads that it was capable of doing were pretty limited. They were ranging from data processing to image processing. They didn't do very much with serverless. They didn't have a very interesting application. Later on, it really took off when AWS introduced API Gateway as an event source for Lambda functions. This was a total game changer, and the community grew more aware of the capabilities that serverless had. Having a great market and seeing the potential, AWS considered it appropriate to invest more in this technology, so we ended up with this great solution and that solves unbelievable problems. But to get back on track, why I'm such a good friend with serverless? Well, it's because it doesn't lack portability. By design, these applications should be lightweight and flexible. They should be able to be expanded or updated quickly. In our case, by using NodeJS, today we're going to use NodeJS in our workshop. By using NodeJS, it means that our solution regained access to serverless computing power from all the major cloud players out there. Of course, this is not the only runtime widely supported by serverless computing. It also supports Python, Ruby, Java, Go, .NET, and some cloud providers even support custom runtimes. It has a reduced maintenance burden. You don't have resources to monitor. It's almost a set it up once and let it run. Of course, you still have to monitor to make sure it does its thing, but let's face it, what app doesn't need to be monitored? Scalability. Theoretically, serverless is infinitely scalable. In practice, each vendor has a limit or a load balancing that they do behind the scenes, and that limit can be increased on demand if it's necessary. We're going to talk about limits a little bit later, as promised. In the same time, it has a fast go-to-market, which is ideal for any kind of companies, startups or not. There's no need for complicated deploy processes to roll out bug fixes or features. And in the same time, it's quite cost efficient. You pay for what resources the function uses for the amount of time it uses them. You pay nothing if the function stays idle. So if you have a function that just does nothing, it works only once a month, you pay for that time, that period that the function runs that one time a month. So about the project setup and requirements. To save time in this 1 hour workshop, I prepare some items beforehand, like the configuration file for the project and the actual code for the PDF generator, which we all know can be a little bit tedious and time-consuming. I personally don't like building PDFs, and every time I see a task in the sprint board, I try to call in sick or invent something, some holiday. I'm gonna try to keep it as interesting as possible while I walk you through the thought process and the concept. Regarding the database, we're gonna use Faker just to mock the database and a random timeout interval to simulate the latency of the network. Another mock service will be the email service, which again, we're doing it just to save time for the demo. For this demo, I chose to use Serverless Framework as it really reduces, so serverless technology and Serverless Framework, as it really reduces the development time and the deployment time. It works with all major cloud providers, AWS, Google Cloud, Azure, and so on. The community behind this project is quite active, and it has plenty of tools and plugins that make development fun for a change. They have pretty awesome documentations, lots of examples, and all kinds of resources, which I encourage you to check them out on their website. So let's dive in. I sketched up a diagram of what our system looks like. So you'll have more context as we actually look at the fun part, meaning the code. So the services that we are using in order are CloudWatch, Lambda, SQS, database, which in our case is a Redshift icon, a storage system where we will store the files once they are done. We are using S3 and a generic email service. As we know, now a little bit about the project, how it works in the real world. As we know, how we got used to, when you subscribe to a service, you subscribe to a certain interval, which usually is about 1 month, from 27 to 27 or from the 1st to the 1st. Most of these services choose a fixed date to issue invoices to the clients, either if it's out of commodity or it's an accounting decision. That really depends from company to company. So our system is configured to run on the 1st of each month. So the CloudWatch rule here will act like a cron job, which will trigger the first Lambda, which will load the data, will process the data, and will feed it later on to the SQS queue. That SQS queue will later, after that, this SQS queue will act like an event, source for the invoice generator Lambda. That this Lambda will later on generate each PDF on its own, will save it to the database, will flag it as generated as processed in the database, and will send the email to the client. All right, so let's take a look at our code. First, we're going to start with the serverless YAML configuration file, most likely meaning with the provider. Provider is a global configuration for this application. And it has parameters like name, which is the name of the cloud provider, in our case, AWS. The runtime can support Node 10, 12, like I said, .NET, Go, and so on. The region, the profile of your credentials, if you have multiple credentials of AWS Cloud or Google Cloud, and so on. And the environment, the role, and so on. Here in the provider, I included the environment, a global environment that will get propagated downwards to the functions. The value of this variable can be overwritten, of course, later on at the function level if we see fit. To continue, we have the function declarations, and currently we have 2 functions here, data loader and processor. And let's take it with the beginning. We have the data loader. with the event that we talked about, the CloudWatch event. We named it. It's going to be called the invoice generator. Oh, by the way, opt stage is a parameter that we will pass from the CLI when we will compile and deploy the function. So it goes like this. We have CLS deploy -s, which means stage. They can also be written like this. And we consider that we're going to deploy to production environment. If we have multiple environments, we can do dev, staging, and so on. So it depends on how we configure our environments. Currently, for this example, I have only the production environment. So the schedule, the cron job rule will be named as, the final name will be prod-invoice-generator. And it will run, as we talked about, at 12 a.m. every first of each month, every year, and so on. The timer for this function is for 300 seconds, 5 minutes. But of course, we can adjust the value to match our needs and, of course, to the respective time that our query needs to return all the responses from the database. So let's dive in deep and review this current function. The handler shows us the path to this function. And it can be found at source-functions-data loader and the export const main. Each Lambda function has a series of arguments, and in our case, we care about the event one more. Event will hold the payload that the Lambda will receive from each event source. This case, we don't care about a certain payload just now. In the next example, we will care. As stated in the presentation, we will have some mocked data that we will generate in order to save time on querying different data sources and so on. With that, after we collected all the faker information, we map through it with a concurrency of 100. So we're going to process 100 items at a time. This promise map with concurrency is available on the Bluebird library that I find very useful. So I recommend it to you all. We iterate through all the messages that we collect from the database, and we push one message at a time in the queue. So again, it will act as an event source to our next Lambda. Let's take a look at the next function, meaning the processor. This function has an event source, the SQSQ, that we are pushing the invoices to in the previous example. We are digesting 10 messages at a time, so each invocation of this function will consist of an array of 10 records. Okay, let's review the function. So EV will contain 10 records at least each time. If we push in the queue 9 messages, our function will run only once. If we push 11 messages, our function will run at least twice, because it's digesting 10 messages at least. At most, sorry. So we load all the messages, and as we got used to in the previous function in the data loader, we are mapping through those records at a concurrency rate of 2, and we are processing each payload at a time. We are, first of all, we are rendering the invoice using PDF Kit. I'm not gonna bore you with the details of what's happening here. We're just generating the header, the customer info, the items table, and of course, lastly, the footer. And after the PDF is done, we're closing the function and returning the file name path, which is unique, so we won't overwrite every time we iterate through the promise. After we save the file in S3, I recommend to save a flag that the file was generated. Why? If the function will crash later on, here, or here, anywhere actually, it is better to flag that the file was generated so we won't repeat the process and regenerate the file, as it may, we may stumble upon issues or bugs, edge cases that we don't want to. So better safe than sorry. After we flag the file as generated in the database, we can start backing it up in the in S3. We can notify the client via email, and at the end, we're closing the function, but not before we delete, we remove the file. Why do we need to remove the file? Each Lambda instance has a limitation in the temp folder of 512 megabytes. So one file, let's consider that one file has 10, 12 kilobytes. We generate 10 files, as this is the size that, the batch size that we configured. We're gonna have a low value there in the temp folder, so we don't have to worry about. But if we want to process larger files, in this case, we should delete the files once they are processed, so we won't fill up the temp folder and end up with some edge cases that we're trying to reproduce and don't understand. A good aha moment here that I want to present you is this case where I'm returning the promise resolve instead of the promise map. So if we dive back into the code, each run of the processor procedure function here will return a value. In this case, it's return resolve. So we're going to have an array of 10 items with undefined, undefined, undefined. But in case this is how it would look. In case our promise map returns some actual values like objects or such, just exactly as it happens in this case, because also in the data loader we have await and return promise resolve. We will end up crashing the entire Lambda, as one of its other limitations is the request and the response payload. For asynchronous invocations, the payload size can be of 256 kilobytes. For synchronous invocations, it is of 6 megabytes. So imagine if we have here 10,000 records, an array of objects with about 10,000 records. It may go over 6 megabytes, which is our limit, and that will crash our Lambda. What will happen when this Lambda will crash? Actually, it will retry the execution. And retrying this execution will put the same message multiple times in the queue, and having the same message multiple times in the queue, we're going to end up generating the same invoice multiple times. And this is why the database flag is useful in this case. So, all right, let's test this code out. Let's take it for a run and see what it can do. A few things that were created beforehand so they weren't included in the serverless deployment, is I created the bucket. I created and configured the bucket, and I also created the Lambda role. Why was it needed for me to create the Lambda role? Well, I like to work in a secure fashion, so I want my functions to have access to the exact items that they need access to. I don't want them to have access to everything, and then when there's a breach, we start digging through everything. So better to have items prepared beforehand than being later on. Sorry. Yes, it's a little bit more maintenance, but it's not that bad. And one last thing that I had prepared beforehand was the SQS queue, because I wanted to configure the delays between sending the messages and so on. Actually, I'm going to deploy, while I'm going to take you through the first demo, I'm going to just increase the numbers so you will see the actual response times for the entire process to generate between 10,000 and 20,000 files. Boom. OK, let's consider that it's the 1st of September and our function, the data loader, gets triggered. How do we do that? Well, we can invoke it via the CLI, from the AWS CLI, or from the serverless CLI, or we can invoke it directly from the AWS console. So if we push test here, I prepared an empty payload. It's going to execute our function, which will wake it up. And it will push messages to the queue. And we're going to see here, the end result is that we will have two new folders in our bucket with the invoice that we needed. So this is from yesterday's test. This is from today's test. So let's see how our invoice looks. Hooray, we have our pretty spicy invoice here for handmade granite shoes. Well, that's new. OK, let's prepare the bucket for the next step. And after the next example, we're going to look at metrics. We still have 10 minutes, so we're going to try to make the most of it. I think the Q&A session will have to suffer, but please, I'm going to stay on the chats, both on YouTube and on Hopin. If you have any questions, we can continue discussing there. OK, so everything was uploaded. Checking stack update. Let's see how our lambdas look, if they were updated or not. Last modify 1 minute ago, so we're good. So if I run the function again, I'm going to expect to see around between 10,000 and 20,000 files in our S3 bucket. And after that, we're going to just jump in to see on the tracking platform called Lumingo and see how everything looks like. So let's hit test and hope for the best. In terms of tracking, you can do tracking and configuring alarms. You can do this via AWS's tools like CloudWatch and creating all kinds of metrics and alarms. But I found it very useful to use a third-party tool called Lumingo. Lumingo presents, basically, it traces all the functions that your account has. And if you if you have, you can configure alerts, you can monitor costs here. Hey to you too, Roy. You can monitor costs, durations. You can set up all kinds of alarms, and it's when you have to debug and understand how the function works, what does it do, it actually looks pretty handy. So the duration, 57 seconds. Well, I think we generated quite a few files. So this is only feeding the SQSQ. So our Lambda function right now, if we look how many messages are in flight, it's 0. That means that our files were already generated. So if we refresh the bucket, we're going to see quite a few files. So I think it took longer to query the database. Actually, it took longer to query the database than to actually generate all those invoices. Okay. Looking at Lumingo to see the performance, let's see if it refreshed. Still 7 invocations, no problem. Takes about a minute to gather all the analytics. As we can see, the duration is almost about 2 seconds, and it costs pennies. When you add up all of this and compare it to having a container opened or something like that, you can consider that it's actually more cost efficient to have it this way. In the same time, we can look here. We can also track. We have a separate tag to view the invocation issues. So these are some errors that I triggered yesterday, so we can see how useful they show up here and how easy it is to track them. On the left, we have the graph, which is actually very, very, very nice. It shows even the source of the initial event. So it shows that the SQS message came from the data loader Lambda, and it was fed to the processor Lambda. If we click it, we will see the event payload from the SQSQ, the environment variable configurations, and of course the error. And from here you can trace back your steps and try to fix the code. Okay, now let's try to go back and save some time on the presentation or on our last 4 minutes. So as I said at the beginning, we have limitations. So a few of them can, I took, as a disclaimer, I took from the AWS website some snapshots. So the most significant ones are the concurrent executions for AWS is of 1,000, but at request, if your system, your architecture requires, you can increase this number to apparently hundreds of thousands. Good luck and congrats if you are there. The function doesn't have an infinite execution time. It has a limited execution time. Before it was 5 minutes, and as I said, AWS saw the potential and they invested a little bit more in the Lambda functions, and they increased that limit to 15 minutes. Other platforms have different values. The environment variables, all the environment variables per function are of 4 kilobytes. And what else is significant? The invocation payload, as I told you, request and response, they are limited for 6 megabytes for synchronous and 256 kilobytes for asynchronous. The one important caveat that, one important aha for the processor Lambda that I want to note is the temp directory storage. The size is for 512 megabytes. That's why I chose to process only 10 batches of files at a time. Yes, we can process more files. We can process around 20, 30, do the math. Do an average of the size of the file that you're generating, and you can start filling up. I would go on around 50, 80 megabytes of this temp folder. But if you need more space, more storage on your Lambda, you don't have to despair that the temp folder is only 512, because you can attach an LFS. You can attach an external drive to the Lambda, and basically you're going to have infinite space on your function. And again, this is the part for the Q&A. If there are any questions, I'm going to browse quickly through Hopin. Wait. Or from YouTube. If not, I want to say we're sorry about technical issues that we had with the Hopin platform. Hope you followed us also on YouTube, and thank you. All the presentation and the code that we had today, all together with the full video, the full cut video, will be found on the link that you see on the screen. bit.ly/SNP-workshop 2020. Thank you for following.